I would like to welcome our next speaker, Mr. Albert Wen, who is the Director of Huawei Digital Power Business, Southern African region, who will share with us the Huawei walkthrough and just give us a general introduction of Huawei.
Hello everyone, welcome to join the FusionSolar Day Webinar. I'm Albert, responsible for the digital energy business in Huawei Enterprise Southern Africa. Here I'll give an overview of Huawei and the Huawei FusionSolar business. As we know, now Huawei is a world-leading ICT infrastructure and a smart device provider. Our vision is to bring digital to every person, home, and organization for a fully connected, intelligent world. Continuously create value for customers, unleash personal potential, enrich family life, and stimulate organization innovation. Huawei adheres to continuous innovation based on customer needs, increase investment in basic research, and promotes the progress of the world. Huawei was founded in 1987. It's a private enterprise owned by employees. Currently, Huawei has more than 190,000 employees engaged in more than 170 countries and regions, which includes about 96,000 R&D employees. We have gained a lot of recognition in our continuous progress. In the fresh news, we are number 49 in the Fortune Global 500. As you know, Huawei was facing great pressure and changes in 2019. Even though we have achieved a sales revenue about 123 billion US dollar, which means about 19% growth compared with 2018. According to the financial reports for this half year, our sales revenue is about 64.9 billion US dollar by June. You can see from the right part, we have 4 business groups. The carrier business, Huawei is the only vendor that can provide end-to-end 5G solution. For consumer business, Huawei's smartphone shipment volume has exceeded about 240 million in 2019. Since last year, Huawei became the second largest smartphone vendor in the world. So I believe this moment, part of you are using Huawei phone during our webinar. Also, in the enterprise business group, we have the global customers to speed up digital transformation. The FusionSolar business is also under this business group. And Huawei established the cloud and AI business group last year, providing computing and AI products and service. Maybe you already heard about Huawei invest more than 10% of its sales revenue in R&D every year. That's correct. Our R&D expenditure is about 18.8 billion US dollar in last year. In the past decade, the total investment is about 600 billion China yuan. From the third-party report, Huawei ranked the number 5 in the world if compared the R&D investment. I think this is a reason that our solution lead in the industry. And this is also why Huawei has accumulated more than 87,000 patents. Half of them are obtained abroad and 90 of them are invention patents. In fact, Huawei is not only leading in ICT infrastructure, we are also experienced in power electronics. Since 2013, we started our solar business. We integrated the digital internet and the PV technology to introduce our FusionSolar smart PV solution. And we are continuously innovating and optimizing throughout the entire life cycle of the PV energy generation. According to the third-party organization data, the string inverter solution were more popular than the central solution since 2017. Huawei only focus on the string solution. Actually, Huawei smart string inverter leading in the solar industry by continuous innovative products and solutions. And we are number one in global inverter shipment since 2015. We have offered about 130 gigawatts string inverters in the worldwide. Here you can see we have so many successful cases in the worldwide. One of the key features of our solution is that it supports customer success with lower level cost of electricity. I think that this is why so many energy companies choose Huawei Smart PV solution. Sakaka project, one of the lowest electricity price projects in the world, ACWA chose Huawei string inverter solution. In India, one of the lowest electricity price project, which named the Hero project, and the capacity about 300 megawatts also use the Huawei string solution. In addition, Huawei is also engaged in joint innovation with large energy groups to conduct research on the future development of PV and continue to lead the development of PV technology. What's the detailed solution we can offer? We can offer different solutions for the 3 PV scenarios. Utility scale PV scenarios, which is similar to the thermal power station in a centralized manner. We offer the 185 kilowatts and 100 kilowatts string inverter. For the residential, we have 2 to 6 kilowatts single phase and 3 to 10 kilowatts 3-phase inverters, as well as the battery solution. Later, we have a topic to launch this solution in Africa. The C&I scenarios such as supermarkets, hospitals, factories, and shopping malls campus, we can offer 12 kilowatts to 100 kilowatt string inverter solutions. Huawei provides the leading and reliable smart string inverter solution in all scenarios. We are professional in string solution, mainly because we are dedicated in it. All our solar solution R&D resources are put for further technology and the next generation string solution development. We can see we have 8 management regional team to service the customer globally. According to the GTM report, our market share of Europe and the APAC area are over 20% since 2018. According to the GTM report, our market share of Europe and APAC area are over 20% since 2018. We have established the 3 competence centers in Germany, Spain, and Shenzhen to help global customers to learn better about Huawei solution or to optimize the PV plant design. Okay, here only give a simple overview of Huawei and the Huawei Fusion Solar business. The later topic will introduce more of our solution. Thanks.
Thank you, Mr. Wen, for the very informative presentation. Let's have a comprehensive understanding of Huawei. We are very privileged to welcome Mr. Niveshen Govender, who is the CEO of SAPVIA, who will speak to the topic pain points and challenges of electric power in South Africa.
Good morning, everybody. Thank you for inviting me to speak at this Huawei Solar Fusion webinar. My name is Niveshen Govender. I'm the Chief Operating Officer at the South African Photovoltaic Industry Association. This morning, I was asked to speak on the pain points of the challenges of the electric power system here in South Africa. But before I do so, just a quick introduction to the organization. SAPVIA is a non-for-profit industry association in South Africa. We promote and develop and grow the PV industry as part of renewable energy here. Our vision, our mission, and our value statements have not changed over the past 10 years. Our vision is still to see solar PV as the electricity generation technology of choice in South Africa and sub-Saharan Africa. Our mission is to vigorously mobilize support for the sustainable growth of solar PV, and we do this with values of cohesion, consistency, and collaboration. The aim is to do this in 2 ways. One is to become a trusted partner to government, so we can lobby for more renewable energy in the policies, and 2 is to promote the members, their products, and their services. In terms of our membership, you can see our membership has grown steadily over the years. The association started in 2010 with 6 individuals coming together to lobby for solar PV and renewable energy in South Africa. We currently stand on over 370 members across the value chain of solar PV. This includes project developers, project owners, EPCs, O&Ms, manufacturers, small-scale embedded generation installation companies, training companies, consultants, and finance houses. So just in terms of the contribution of solar PV to date, so solar PV has contributed to the energy system in South Africa. We have 1.5 gigawatts of installed capacity through the utility scale renewable energy IPP procurement program. There's an additional 813 megawatts still under construction that should be coming online within the next 6 months. And we assume that there's over 1 gigawatt of small-scale embedded generation installed capacity across the country. This is application of commercial, industrial, and residential application. In terms of some of the socioeconomic contributions, solar PV shareholding of these projects are up to 40% Black shareholding or South African shareholding. We've created about 25,000 jobs across the sector. The cost of solar PV has reduced by 75% in the last 8 years. There's about 80 billion investment, foreign direct investment coming into South Africa through solar PV. With the generation capacity that we have from solar PV, we are able to light up 1 million average households in South Africa. And build time of solar PV has been reduced to between 12 and 18 months for a utility scale 75 megawatt plant. In terms of understanding the energy crisis and coming to the topic I was asked to speak about, there's a number of keywords that we've put up here, and this is tracking conversation about the energy crisis in South Africa. And this is from our friends at the Energy Desk that has put together the keywords that have come out in terms of how industry is relating to the energy crisis and responding to the energy crisis. And you'll see what's interesting here is two of the biggest words you can see is Eskom and cost. So the cost of electricity is rising, and Eskom as an entity needs to be looked at how to deliver energy better in the country. Just in terms of the complexity of renewable energy in South Africa, I've done a policy overview in terms of all of the policies related to solar PV and renewable energy. And we start with the National Development Plan. The National Development Plan sets out the widespread vision of how we alleviate poverty and reduce inequalities in South Africa. The new growth path identifies key areas, especially for infrastructure development and how renewable energy fits into that, to the requirements of infrastructure development. The local procurement accord is basically talking about localization and how we can manufacture locally and how we can implement local content rules and requirements as part of the procurement of renewable energy. The Green Accord, the Green Economy Accord is an agreement between the social partners, government, labor, business, in how we will create jobs and how renewable energy will contribute to those jobs that have been created. The Integrated Energy Plan is the general energy plan for the country. It looks at energy security, access to energy, reducing costs, energy supply, energy efficiency, and how energy is planned in the country. The Renewable Energy White Paper talks about our goals for renewable energy and how we should invest and roll out renewable energy in South Africa. The two policy papers that I will be talking about a little bit more in the presentation is the IRP, the Integrated Resource Plan, and this shows us the energy mix that is coming in the next 10 years. And the second one is the Electricity Regulation Act Schedule 2, and these are just the guiding documents in terms of licensing and registration, and this is applicable to small-scale generation plants, particularly when you're looking at commercial, industrial, residential applications. So when you talk energy crisis or energy power systems, we cannot get away from load shedding. So for the last 12 years, South Africa has had load shedding. We're still no closer to a solution than we were 12 years ago. And we've pinned this down to a simple demand versus supply problem. And when you look at the demand supply curves, the reason for the lack of supply is due to the energy availability factor. And when we look at the energy availability factor, the IRP states that we are currently under 70% and we need to be over 75% of energy availability. And there's a number of reasons as to why we are not achieving this target. So one was for us the delay of signing with window 4. Would we have signed these projects earlier on, we would have had this capacity on grid by now. The delays has caused new capacity not being connected to the grid as quickly as possible. We also looked at Medupi and Kusile, the two mega projects for coal that is running behind time, over budget, that is not online. Operational plant maintenance, so we hear that plants are breaking down, plants need to be taken offline to be maintained. A number of issues with the current fleet of Eskom, and then the fuel supply. So the quality of coal with the weather being wet, not being delivered on time. There's a number of reasons that that can be included in here, but what we bring it down to is planning, and we need to plan the system better to ensure that our supply and our demand matches each other. So what is the solution? We are in load shedding 12 years later. What is the solution? We can go on complaining, but we need to have a solution as to how we move forward. The solution from a renewable energy point of view is new generation capacity. We need more generation, and we believe through wind and solar PV would be the best option for the country. We assume that we require more than 6,000 megawatts of wind and PV to be built. And we need some battery storage to level out, to stabilize the grid so it's dispatchable energy. And we believe this can be achieved in the next 18 months. So yes, now we have a solution. How do we implement the solution? I'm going to talk about the enabling policy. So we have an integrated resource plan that was published last year, 2019, October 2019. And the integrated resource plan pretty much sets out the plan for the next 10 years of how we're going to have new generation capacity, additional capacity, and with the decommissioning of the coal plants, how will we fit the gap? So as you can see from this IRP, the lion's share of the new generation capacity comes from wind and PV. Those numbers in green are the 1,600 megawatts per year of wind, and the 1,000 almost every year of PV is the biggest share of new generation capacity coming online. And then there's a new column that was introduced to the IRP, which is under other, which covers distributed generation. And for us, distributed generation is small-scale embedded generation plants. From the technology options available in South Africa, solar PV has the best chances of delivering energy quickly and cost-effectively. So you say, we have an energy plan. What are the hurdles? What are the pain points? Why aren't we implementing? So just in terms of this integrated resource plan, so from a solar PV point of view, the first problem we see is the allocation gaps. So we believe that to build a sector successfully and sustainably, you need consistent procurement of renewable energy, and solar PV specifically in this case. And the gaps within the procurement here does not allow for localization, does not allow for local content, local manufacturing. So the opportunities are missed in terms of having consistent procurement across PV for the next 10 years. The second pain point for us is the distributed generation, or the other column. So this is low-hanging fruit in South Africa. We need more conducive environment to be able to build commercial, industrial, and residential plants with PV in South Africa. So for us, this is low-hanging fruit, and if we enable the environment for the industry to actually undertake building projects within this space, we would have a lot more energy a lot quicker to the grid. So in general, the point that I want to make on this slide is that we need to expedite implementation, and this sits within the framework of the Minister of Energy, so it's within his control to expedite this implementation and make sure that we are rolling out new capacity as quickly as possible. The next policy paper I want to talk about is the ERA Schedule 2. So the Electricity Regulation Act actually regulates how electricity is generated in South Africa. So for solar PV, especially with the small scale embedded generation plants, so this is anything under 10 megawatts, you would require two things in the past. One would be a minister's deviation from the IRP, because the IRP never had the distributed generation column before. And this is now been replaced. So you don't require the minister's deviation any longer. The IRP now has a column for distributed generation that these plants fit in. So this requirement has been removed completely. The second one is a generation license. So by the Electricity Regulation Act, every plant generating electricity requires a license. No matter how small that plant is, even if it's a 1 kilowatt system on a roof, it requires a generation license. And this was becoming difficult for the industry. So we had lobbied hard with to exempt smaller projects from licensing. And what has happened is that the Department of Energy has produced a Schedule 2, which exempts licensing for any plant under 1 megawatt connected to the distribution power grid within a number of categories that they have provided. So this also alleviates some of the pain. So the pain points on here, on this policy paper specifically. So one, we see the bulk of the allocation up until 2024 is being used for emergency procurement of projects between 50 and 450 megawatts. So this doesn't really fit into the commercial, industrial, residential application. So government has used more than 70% of the allocation for mega scale projects. The second pain point is the 1 megawatt cap. So there is an arbitrary number of 1 megawatt that has been applied to exemption of projects, and we believe this is a missed opportunity. So if this cap was increased to 10 megawatts, for example, we could have a lot more projects a lot quicker at no cost to government, because this is private investment into these projects. So for us, it's a missed opportunity and really needs to be looked at as a cost-effective and quick solution to the energy crisis we find ourselves in. Number three, the rules and processes. So yes, we have a regulation that says that projects under 1 megawatt is exempt, but there are no rules and processes readily available for the industry to participate in. So this needs to be developed by the regulator and released by the regulator, so project owners and project builders are able to follow the rules to be able to build these projects, exempt them from licensing and register them as required. And I think the last pain point that I have is the implementation. So the implementation, although we see moves in the right direction of policy opening up and environment opening up, to practically implement these projects is difficult. So we're seeing that it's impractical. The processes are not really practical with your system distributor, with your system operator. So when you're trying to build these plants on the distribution network, you need to have connection agreements with your operator and your distributor. And these processes are also not well defined and do not fit within the requirements from the regulator. So you have different opinions coming in from policy, coming in from the regulator, coming in from the system operator. The process has not come together where it's a straight line process that you can follow. So I think that sums up my presentation this morning. I would like to leave you with this slide that I found of an ESCOM presentation in 2008. And I think it sums up very nicely where we're coming from and what needs to be done going forward. For us, the future is solar PV. The opportunities are rife within the commercial industrial space. It's quick to market, it's cost effective, can be done fairly quickly. Thank you.